All right, so in this lesson, we will interpret sequences and represent them using equations. All right, so I am going to give you an example of something called an arithmetic sequence. All right, so a sequence is like this is a sequence, 2, 5, 8, 11. It's like a list of numbers, and we're going to talk about what would make this list of numbers an arithmetic sequence or a geometric sequence. But we're going to do arithmetic sequence first. Like right here, we can tell that, let me do it in a different color. We can tell that we added 3. We added 3. We added 3. This is what makes this list of numbers not just a list, but a sequence of numbers. Right here, we can see that 16 to 14 is minus 2, minus 2, minus 2, minus 2. This is also an arithmetic sequence because even though we're subtracting, it's like, think about it as in we're adding a negative number, we're adding a negative number, we're adding a negative number. So an easy way of figuring out if it's arithmetic, if we have an arithmetic sequence, is if you're adding or subtracting by the same number over and over and over again. And by the way, these dot dot dots means that it keeps on going. Like this one's still minus 2, this one's plus 3, it just keeps on going forever. And okay, now we have situations like this, right? Where we're like, well, what do we do here if we're not comfortable, right? Well, right here, 5 minus 2 is 3. 14 minus 16 is negative 2. So all we have to do is take this number, subtract this number. So negative 19.5, subtract negative 20, and we get negative 19.5 plus 20, which equals positive 0.5. So that's plus 0.5. Remember, we subtract going this other way, just so you know. We always subtract going backwards. Like if we're going forwards, if we're trying to find out what we're doing to go to the right, then we go to the left. So we would do 19.5 minus negative 20. Or let me try to make that one a tiny bit better. Okay. Or we could subtract negative 19 minus negative 19.5, or so on and so forth, right? So this is plus 0.5 and plus 0.5. And don't forget that this is that's the number we are adding by in this case. And let's do that right here. I'll put a star. So this is our general equation. So this is our equation for arithmetic sequences. So this is our equation. We'll just put it here, arithmetic sequences. This A1 is the first term. Like for instance, the first term here is 2, the first term here is 16, the first term here is negative 20. This plus D is the common difference. It's what you're adding by, so adding or subtracting. And then this is our term number. We'll go through all this. So let's look at example number 1. So it says a sub n, or a sub n equals 10 plus 2 times n minus 1. So right here, this common difference is positive 2. You can just put 2 if you want. And we start off with a 10. Actually, you know what I'm going to do? I'm going to, I made the common difference here in this color. I'm going to make it in this color too. Okay, that way when we come down here, we could say that the common difference is plus 2. And we'll say that the first term is 10. So we start off with 10, and then we add 2. And then we add 2. And then we add 2. And so on and so forth. So we get 12, 14, 16, we keep going, 18, 20, and then you can put dot, dot, dot. Just put like 4 or 5 of them, right? So the first term, a sub 1 is the first term. The first term is, or was, 10. The second term is 12. The third term is 14. So 1, 2, 3, 4, 5. The fifth term, pay attention to the number. The fifth term, 1, 2, 3, 4, 5, is 18. So I'm actually going to do orange. This is our first term. This is our second term. This is our third term. This is fourth term. This is fifth. This is sixth, right? So let's do this. We have a sub n equals 20 minus 0.5 times n minus 1. So our first term, well, yeah, our first term is 20. So our first term is 20. Our first term is 20. And our common difference is negative 0.5. So we're going to do minus 0.5. Minus 0.5. So let's do that. So that's 19.5, 19, 18.5, 18, and we'll put 17.5 here. Remember that this is the first term, this is the second term, this is the third term, this is the fourth, this is the fifth, and this is the sixth. So my second term is 19.5, my third term is 19, my fourth, oh, it's actually for my fifth, is 18. Cool. So let's represent these. Okay, so let's label our first term. Our first term is 3. And let's find our common difference. So our common difference will be like 5 minus 3, or 7 minus 5, or 9 minus 7. Any of these will do. You don't have to write them all out, which is 2. So remember my equation starts off with a sub n equals my first term, which is 3, common difference, which is 2, so I'm going to put plus 2, and then we put the n minus 1. So let's prove this, okay? So I'm going to write a sub n equals 3 plus 2 times n minus 1. Now let's pick a term. So this is like my first term. This is my second. This is my third. This is my fourth. This is my fifth. Let's do our fourth term here. So a sub 4, I guess. A sub 4. Oops, that was supposed to be orange. Equals 3 plus 2 times 4 minus 1. So just to be clear, this is our fourth term, so we put in a 4 there. So we end up with a sub 4 equals 3 plus 2 times 3. 2 times 3 is 6. So a sub 4 is 9. 1, 2, 3, 4. A sub 4 is 9. Good. Which is correct. Let's see. So actually, I'm going to skip this next one. I'm just going to jump to example number 5. So it says, what equation can represent? So a sub 5, or a sub 5 and a sub 6. So it gives me the 5th term and the 6th term. So if I write these out, 4, 5, 6, it tells me that my 5th one is 15 and my 6th one is 14.5. To find my common difference, well, because I got to get back to this one, right? I need to know the first term. So to find this common difference, I need to do 14.5 minus 15, which is negative 0.5. That means this is minus 0.5. And that means I need to go backwards by adding 0.5. So I end up with 15 plus 0.5 is 15.5. And then I get 16. And I get 16.5. And then I get 17. Okay, so this is my first term, remember? So I start off with, well, I'm going to write a sub n again. A sub n equals my first term is 17. I subtract 0.5. And I multiply that by n minus 1. Cool. So I'm going to show evidence that this is correct. A sub n equals 17 minus 0.5 times n minus 1. And 1, 2, 3. I'm going to choose an easy one, like this third one. So I'm going to put this 3 here. Oops. I'll put this 3 here. And I'm going to do I don't know why I switched it to purple, but a sub 3 equals 17 minus 0.5 times 3 minus 1. So a sub 3 equals 17 minus 0.5 times 2. And so I get a sub 3 equals 17. This is multiplication, so minus 1. A sub 3 equals 16. And let's check. A sub 3 was, or the third term, was 16. Cool. Let's look at the next page.